Okay, so we're going to work through the solutions to the norm, distance, and angle problems. So the first one here is in R2. It asks us first for the inner product of u and v using the inner product. That's just the standard inner product of u dot v. So this is going to give me 3 times 5 plus 4 times negative 12, which is 15 minus 48, which is negative 33. Part B of the problem asks us for the magnitude of u, which is the square root of the inner product of u and u, which is the square root of 5 squared. Oh, sorry, that's not correct. It's 3 squared. 3 squared plus 4 squared, which that one's pretty straightforward because it's 9 and 16. That's 25, which makes that 5. C, we want the magnitude of v, which is the square root of EV times v inner product. So this is going to be the square root of 5 squared plus negative 12 squared, which works out to be 169, which is 13. And part D says, what is the distance from u to v, which is the magnitude of u minus v, which is the magnitude of negative 216, which works out to be the square root of negative 2 squared plus 16 squared, which is the square root of 4 plus 256, which is the square root of 260, which I think works out to be 2 times the square root of 65. All right, so that's problem number 1. Let's move on to number 2. All right, so problem number 2 is in R3. So let's look at A. We need the inner product of u and v, which is going to be 2 times 8 times 8 plus 3 times 0 times 3 plus negative 8 times 16. So this gives me 128 plus 0 minus 128, which makes the inner product 0. Part B says, what is the magnitude of u? So that's the square root of u times u inner product. So this is going to be the square root of 2 times 8 squared plus 3 times 0 squared plus negative 8 squared. So this is 128 plus 0 plus 64 would be the square root of 192, which comes out as 8 times the square root of 3. Alright, so let's look at C. We want the magnitude of V, which is the square root of V times V. So this is going to become square root of 2 times 8 squared plus 3 times 3 squared plus 16 squared, which is 128 plus 27 plus 256, which is the square root of 411. Part D is, what is the distance from vector u to vector v? And that's the magnitude of u minus v. So this is going to become the magnitude of 0, negative 3, negative 24. So that's the square root of 0 squared plus negative 3 squared plus negative 24 squared, which is 0 plus 9 plus 576, which is the square root of 585. All right, so that's problem 2. Okay, so problem 3 is an inner product of matrices. So we have the inner product of A times B, which is going to be 2 times 2 times negative 2, plus negative 4 times 1, plus negative 3 times 1, plus 2 times 1 times 0. So this one is going to be negative 8, minus 4, minus 3, plus 2, which works out to be negative 13. All right, so that's part A. Part B asks us for the magnitude or the norm of A, which is the square root of the inner product A. So this is going to be 2 times 2 squared, plus negative 4 squared, plus negative 3 squared, plus 2 times 1 squared. So let's see, that's 8, 16, 9, and 2 becomes the square root of 35. Part C says what's the magnitude of B, which is square root of B inner product B, which becomes 2 times negative 2 squared, plus 1 squared, plus 1 squared, plus 2 times 0 squared. So that's 8 plus 1 plus 1 plus 0 is the square root of 10. All right, part D says what is the distance between matrix A and matrix B given this? So that's the norm of A minus B, which is going to be the norm of the matrix 4, negative 5, negative 4, 1, which is square root of 2 times 4 squared, plus negative 5 squared, plus negative 4 squared, plus 2 times 1 squared, becomes, let's see, that's 32, plus 25 plus 16 plus 2 is the square root of 75, which is 5 radical 3. All right, so let's keep going from there to number 4. All right, so problem number 4 does this with the polynomial inner product. So we want P times Q. It's going to be 1 times 0 plus negative 1 times 1 plus 3 times negative 1. Should give me 0 minus 1 minus 3 should be negative 4. The magnitude of P is square root of the inner product of P times P. So that's square root of 1 squared plus negative 1 squared plus 3 squared. So this is 1 plus 1 plus 9, square root of 11. Part C is, what's the magnitude of Q? So that's square root of Q times Q. So that's 0 squared plus 1 squared plus negative 1 squared, which is square root of 0 plus 1 plus 1, which is square root of 2. Part D asks me for the distance between P and Q, which is the magnitude or the norm of P minus Q, which is going to be the norm of 1 minus 2x plus 4x squared, which is square root 1 squared plus negative 2 squared plus 4 squared, which is 1 plus 4 plus 16, which is the square root of 21. Alright, so that's number 4. Let's move on to number 5, which gets a little more complicated. Problem number 5, part A, we have the inner product of f and g is the integral from negative 1 to 1 of x e to the x dx. This is an integration by parts problem, so let u equal x, let dv equal e to the x dx. That means that du dx is 1, which means that dx, well, du is equal to dx. Take the antiderivative of both sides. Here we get v is equal to e to the x. So we should be able to rewrite this as u times v minus the integral of v du. So this is going to become e minus, so it's going to be plus 1 over e minus e to the x from negative 1 to 1, which is e plus 1 over e minus e plus, no, minus, that's going to be minus 1 over e. So the e's fall out. This is going to give me just 2 over e for that. And then we'll get a new screen for parts B and C here. So part B asks for the norm of f, which is the square root of f, inner product f, which is the square root of integral from negative 1 to 1 of x times x is x squared dx. So this is a third x cubed from negative 1 to 1, which is a third times 1 minus negative 1 is going to give me 2/3. Square root all the way along. All right, so let's look at C. C wants the norm of G, which is square root of the inner product of G with itself. So this is going to be square root integral negative 1 to 1 of e to the x times e to the x is e to the 2x dx. So that's going to give me 1/2 e to the 2x from negative 1 to 1, which is 1/2 times e squared minus 1 over e squared. So, I don't know, let's see, can we simplify this up some? E squared over 2 minus 1 over 2e squared. 2e squared, nope, that's not correct. E to the 4th minus 1 over 2e squared. I think it's as good as we're going to get there. So that's A, B, and C. Part D of the problem says what is the distance from F to G, which is the norm of F minus G, which is the norm of X minus e to the X, which should be square root negative 1 to 1, X minus e to the X dx squared, right? Because it's times itself. All right, so expanding that, we get x squared minus 2x e to the x plus e to the 2x dx. So we break the integral apart. We get negative 1 to 1 x squared dx minus 2 times the integral from negative 1 to 1 x e to the x dx plus the integral from negative 1 to 1 e to the 2x. And the advantage of doing that is we know what all of these integrals are from previous work. So we know that this one comes out as 2/3. We know that this one comes out as 2 over e. And we know that this one comes out as e to the 4th minus 1 over 2e squared to the 1/2. I'm going to leave it there because that is a complete value. I think I did some work trying to simplify it in the notes, but you can just leave it there and we'd be good. All right, so let's look at number 6. All right, so 6 wants the angle between the vectors. If I use u and v here, when I take the inner product, I get 1 times 2 plus 2 times 1 times negative 2 plus 1 times 2, which comes out as 2 minus 4 plus 2, which is 0, which is fantastic because that means that the cosine of theta is 0 over the norm of u times the norm of v. Neither u nor v are the 0 vectors, so this just comes out as 0, which means that theta is either 90 degrees or in the other phrasing of things, it is pi over 2 radians. All right, so let's look at part B. Says, what is the inner product of P and Q? All right, so we need to take the inner product of P to Q to get to the law of cosines. So it gives me 1 times 1 plus negative 1 times 1 plus 1 times 1 comes out as 1 minus 1 plus 1 is 1. All right, so we have to go a little bit further here. We need the norm of P, which is going to be the square root of 1 squared plus negative 1 squared plus 1 squared, which is the square root of 3. We need the norm of Q, which is 1 squared plus 1 squared plus 1 squared, which is also the square root of 3. So the cosine of theta should equal PQ over norm P times norm Q, which is 1 over root 3 times root 3, which is 1/3. If we take the inverse of theta there, you're going to get that theta is approximately 70.529 degrees, or if you did it in radians, you're going to get it as approximately 1.231 radians, taking the inverse cosine of both sides. All right, so let's look at the last part of it. Okay, so the last part of the problem C here is let's start with the inner product of f and g. Comes out as the integral from negative 1 to 1 of x cubed dx. It's going to become 1/4 x to the 4th. And this is fantastic because that's 1/4 of 1 minus 1, which is 0. So this means that the cosine of theta is 0 over the norm of f over the norm of g. Neither of these is the 0 vector, so that's 0, which again means that theta is either 90 degrees or theta is pi over 2 radians, because these vectors are somehow considered orthogonal. All right, so that's it. There you go. There's the problems.